Good morning, ma'am. My name is Karishma Goswami, and today we'll perform an experiment to study the photoelectric effects. So, before performing these experiments in virtual labs, we will discuss the what is photoelectric effect and some of the characteristics of photoelectric effect. So, the phenomena of emission of electrons from a metallic surface when the light of suitable frequency is allowed to fall on the surface is known as the photoelectric effect. The principle of photoelectric effect is based on the law of conservation of energy. So when the photons are incident on the metallic surface, they transfer their energy to the electrons and the electrons get ejected from the metallic surface. So in this process, the overall energy of the system remains conserved. These are the basic characteristics of photoelectric effect. And like the threshold frequency varies with material and it is different for different materials. The photoelectric current is directly proportional to the intensity. The kinetic energy of the photoelectrons is directly proportional to the frequency, and the stopping potential is directly proportional to the frequency, and the process is instantaneous. So we will verify these characteristics through our experiment in virtual labs. Now we'll go to virtual labs, and in virtual labs we will go to modern physics lab. In modern physics lab we will go to photoelectric effect. So now to perform the experiment we'll go to the simulator. So as we know that the virtual lab simulator is coming with pre-implemented circuit, so we don't need to implement the circuit, and to perform the experiment in virtual labs we get a source of light through which light is incident on the metallic surface and a power supply is connected to the metallic surfaces to vary the amount of voltage, and an ammeter is connected to it to detect the amount of current. So by switching on the light, we can vary these four parameters. So here we can also choose a metallic surfaces like copper, sodium, zinc, platinum, and we can vary these four parameters. We'll see one by one these four parameters. Let's start with the area of plate. Now if we increase the area of the plate, that means more number of photons will fall on the surface because the surface which is exposed to light will be increased. So like this we can change the area of the plate, and here we can increase the intensity of light. So as we know that the increase in intensity of light will leads to the increase in the photocurrent, but the stopping potential will remain the same. And from here we can change the applied voltage, and here the applied voltage is negative because it is the reverse voltage, and from here we can change the wavelength of the incident light. And now we will try to plot a graph for different intensity of light at constant frequency. For doing so, we will vary the applied voltage till the current in the ammeter becomes 0. So as we can see that at 7.8 volt our current is becoming 0, and we'll take the readings of current and voltage to plot the graph between photocurrent and stopping potential. Suppose we plot for three intensities. Say we plot for 10 watt per meter square, 20 watt per meter square and 30 watt per meter square. And now we'll vary this one by one and we'll take the readings for voltage and current. So for 10 watt per meter square, our stopping potential is 7.8 volt. Now if we see for 20 watt per meter square, stopping potential is also 7.0 volt, and for 30 it is 7.8 volt. So as we can see, the stopping potential for all the three intensities are same, as increasing the intensity only increases the photocurrent, but the stopping potential remains same. So let's see the graph which we have plotted for three intensities. So here we have plotted the graph between photocurrent and stopping potential for three intensities: 10 watt per meter square, 20 watt per meter square and 30 watt per meter square. And these are the values for stopping potential and these are the values for photoelectric current for their respective intensities. So from the graph we can see that increase in the intensity means the photoelectric current will increase, but the stopping potential for all the three intensities will remain same. So from this graph we can verify this characteristic of photoelectric effect. And now we will try to plot a graph for different wavelengths of light at constant intensity. Let the area of the plate to be at 0.1 centimeter square and the intensity is kept constant at 30 watt per meter square. Now we will vary the reverse voltage till the current in the ammeter becomes 0. And we will take the readings of current and voltage to plot the graph between photoelectric current and stopping potential at constant frequency. Suppose we plot the graph for three wavelengths, say 100 nanometer, 120 nanometer and 140 nanometer. So as we know that wavelength is inversely proportional to the stopping potential, so the light with greater wavelength will have lower stopping potential, and this we can verify with this simulator. So for wavelength 100 nanometer, volt stopping potential is at 7.8 volts. Now for 120 nanometer, the stopping potential is at 5.7 volts. So as we can see, as the wavelength is increased, that stopping potential is decreased. And now let's see the graph which we have plotted for different wavelengths. So here is the graph for different wavelength of light at constant intensity. So these are the wavelength at 100 nanometer, 120 nanometer and 140 nanometer, and these are the readings for stopping potential and they are their respective photocurrent. So as we can see from the graph that increase in wavelength would lead to decrease in the value of stopping potential. So hence we have verified the characteristic of photoelectric effect. So from the experiment we can also verify the value of stopping potential for different metals. Suppose for copper we obtain the stopping potential at 7.8 volts. So we can also verify this experimental value by using a theoretical formula. Stopping potential is equal to H by E into nu minus nu naught. So by putting the values we got the stopping potential at 7.7785, which is approximately equal to the experimental value. So we can also verify the value of stopping potential from this experiment. So this was the procedure which we have to follow to study the photoelectric effect. Hope you like the video. Thank you so much.